Giza Pyramid Project, Extended Mechanics. For those of you who are following the system, the third pyramid over is just under half the height. We can get into the exact math later, but just keep in mind that I'm going to blow this up because the key's inside of here, and I'm going to also blow up the inside here, but proportionally the whole system is the lower half of the structure. But within the third pyramid there's a niche, the tail that goes down below ground. This goes down to just below the elevation of the bottom of the hallway, the pool within the Queen's chamber. The elevations up here are going to marry with, in the King's chamber, this elevation should be the elevation at the bottom of the pool within the King's chamber that the hydrogen bubbles into. The bottom of this should be the elevation at which the inlet to the King's chamber, which is in there, that should be that elevation, and the top of that shaft should be the elevation where the boss mark spills over. Actually, it's probably the top of that, but that's the elevation that the boss mark spills over down in the antechamber. And the top of this, I believe, is the elevation where the hydrogen actually comes into the structure above the King's chamber, where this is the actual elevation at the top of the King's chamber, the very top. So that is how I currently see the elevations. Now, when we get into the inside guts, we have a whole lot more with the elevations of the hallway within the Queen's chamber and the pool, where I discussed the elevation at which the ground goes to out there, the antenna that grounds. Out here, we work within that nice configuration they have on the front, showing us the elevations and the pools. I kind of should move this over so I can draw it. The spillway that comes down into the pyramid, and then within the pyramid, the hallway that goes into the Queen's chamber, which, that could be at that level. You've got the, working with the markings on the outside. This is going to be the elevation at which, where the Grand Gallery joins with the ascending shaft, and you've got the well pit there on the side. If we blow that up at where it meets the wall, that elevation should be that elevation. Of course, I'm working with different size scopes here, but these should be synonymous. And actually, yeah, no, that's right. Then you've got the spillway, the actual one that spills into the system, which is at the lower elevation. That one should be at the level of where that pit, the last pit here, which is to the side of that opening, it's just below the bottom. That should be at the elevation just below that, but it will be at the elevation of this spillway right here, the one that actually goes into the system, maintaining pressure within the system at that elevation as if you were within the water on the outside. How much pressure you would have to push down on that, whatever that bars of pressure, the pounds per square inch, kilograms per square meter, whatever it is, that pressure is the pressure that is maintained or maintains the elevation of the high peak of the waters within the this whole system. And then to allow for seepage, the spillway on the side, there's one spillway which allows a more dense liquid out, and then you have the spillway across the bottom. That spillway is in line with that right there. So that actually, it's below it, about 3 or 4 inches below it. Could be right at it. I mean, these guys may have had it down to the millimeter. Let's say it's right at it. Yeah, no, it could be dang right at it. Why not? They had this thing pretty perfectly engineered, and it actually has to do with, when you look at the system, you see 2 elevations. When you look dead on, you see one elevation, and then there's a little bit of a break, and then a lower elevation. That lower elevation is actually the inlet for the waters that come into the system, and this higher elevation, that actually marries with what I'm talking about here. That maintains the elevation that the airs, one of the air pressure, the outs going out, would maintain at in order to get out of the system, and that would maintain the air pressure, actually the gas pressure, that is the buildup in the updraft. That would maintain the gas pressure, and the spill valve, the outlet, the main outlet, is the one tunnel you see to the side when you look straight at the main entrance area that has the steps to the side of it. There's like a little tube over to the side with another tube right above it. That's actually the primary outlet to maintain the pressure within this bubble right here, which is actually that bubble there. This would kind of be squished to the front a little bit. The maintaining of the water levels is one area, the maintaining of the gas levels is at another. That way, you know, each one is controlled itself. And that's how we will rebuild the system. But this allows the bottom of this, which should line up with one of these actually, will be, should actually go below, probably down almost as deep as here, maybe a third of the way through there. Don't know. We'll have to actually play with that modeling, because they're separating out densities of water. It may just be heavy water and light water, but I believe they're actually playing with other densities of water. There's also that kind of goo gel water that we have that's down between 0 and 4 degrees Celsius. Depending on how you can set the atmosphere, you may be able to, you know, manufacture that goo gel. Goo gel. You know, so we may be looking at another form of water, another stage of water, and they may be pulling that stage of water out, and maybe that's the least energetic stage of water. I don't know. This is what experimentation will come to. Now, within the room, also you have the area, the gas, and it's dictated by the top of the tail of the Queen's chamber, and the elevations in there we're going to work with when we get this whole system running, to work with the elevations within the outlet up here. Those will line up with the elevations of the top of the niche that goes into the tail, and the water levels actually line up with the bottom. The bottom of them lines up with these squiggles, and what we're doing is we're pulling the water level up within the system, maintaining the pressure on the top of it on 2 areas of the system to be at a higher density, a higher pounds per square inch. It's the gas bubble that's maintained by the pressure, which is dictated because we can calculate the volume of the pool when we get all the numbers in line. It's like a big Mensa puzzle here. So we can calculate the foot-pounds of pressure and all this stuff. It's all calculatable. It's a pool within a pool within a pool. Now, once we get this down, and we start to see some reaction within this particular queen's chamber where we're going to get the drip, which is slightly off center in the room, and we're going to probably see a spark because we got all the static electricity that's built up here that's brought down within the system. Whatever we're going to get there is going to then be echoed into the center chamber of the pyramid next door. And that is where this, I believe, is doing some sort of a creep, you know, the same way heavy water does this little creep, that we're going to pool some of that into this structure, which is at an elevation that will be below the mean water level outside the system. So we're going to get some sort of a weird condensation in there. Exactly how, what, or why, again, this is what modeling is for. And fortunately, computer modeling only dictates what the computer was taught. This may have to be some sort, get into natural computer modeling. Anybody who's willing to aid me with this, I will go over as many details. There's a whole lot more to it. When you look at the pressures within the king's chamber and how they're maintained as well, the, they like to call the king's chamber, the combustion chamber, and that's going to pool off and be maintained by the reaction itself. As the reaction goes too much liquid is created, then it chokes itself off. And then as the water level recedes, so we're going to have a spillway or a pool right there, and that is going to allow that system to pool up and maintain and control itself. And then we're going to capture the ambient water vapor and then pipe it down the system and into the system, and that will carry down with it the static electricity which is building up within the outside of the structure, conveniently because of the way they engineered it. So the steps do like a sweeping pattern, and how we have a nice little barrier at the 35th level, and how, even though I drew it deceptively, there is no top except for today where we put the antenna on top to vent the nasty static electricity which is still gathering to the top of the structure today. But that static electricity is the harvest these guys are looking for. Clear as day. Drank fizzy lifting drink. Walls must be clean and sterilized.